In this lab, we will look at the trace and ensemble methods. The purpose of this lab is to get experience with the performance of tree-based models and some ensemble methods. Step 1. We will read the data from file. The data source for this file is from the UCI Machine Learning repository. We are going to use the QSAR biodegradation dataset, the description of which can be found here in address https://archive.ics.uci.edu/datasets/qsar plus biodegradation. If I click on this, it takes us to the website, and this is the file that we can download. And there is no missing values. As we can see from here, from the description, there is no missing values. So let's go back to the file. The data is being downloaded and converted into a CSV file. Special characters such as percentage, brackets, and the curved bracket and the square bracket and the dash are all removed from the original variable names. A local copy is being saved and read into R as follows. Let biodeg equal read.csv of the file name with the extension CSV, comma, strings has factors equal true. So the strings are read as factors. Print the first few rows. So head of biodeg prints the first 6 rows, and we can see that class has the string values, and these are read as factors. So dimension of biodeg file is 1055 rows and 42 columns. And we check the summary of the data frame. STR of biodeg gives us data frame of 1055 observations of 42 variables. SP max L, JDZE, they are the numeric values. NHM, F01NN, F04CN, NSSC, NCB, they are all integers. C is numeric, the floating decimal numbers. NCP, N0, F03CN, S are the integer types. HDSSC, HYWIBM, log, SMC6L, they are the numeric values. F03CO is of integer type. ME, MI, they are the numeric types. NN, NN, NAR, NO2, NCBX3, they are of integer type. SPPOS, ABP is of numeric type. NCIR, B01CBR, B03CC1, BN073, they are of integer type. SPMAXI, PSII1D, they are numeric types. B14CBR is of integer type. HD0, T12L are of numeric type. NCRT, C026, F02CN, NHD0N SPON, they are of integer type. SPMax BM, PSIIA, they are of numeric type. NN is of integer type. SM6BM is of numeric type. NARCOOR, NX are of integer type. Class is of vector type with two levels, NRB and RB. So the first few lines printed the first 6 lines of RB with the class RB, and in this HDR of biodeg gives us class with vector 2 levels and NRB RB. So RB is read as 2. Because the first 6 values, if you look, they are 2 and the 2 levels are NRB and RB. So summary statistics of the data frame, summary of biodeg. So we can see this is the summary of, and class NRB is with 699 values and RB is with 356 values. Unique of biodeg class, so we don't need this because summary of biodeg gives us the 2 classes. The data set has 41 predictors, molecular descriptors, and one response variable, which is class, which has 2 levels, RB, ready biodegradable, and NRB, not ready biodegradable. Step 2. In step 2, we look at exploring data analysis. So exploratory data analysis. Make ourselves comfortable and familiar with the data set is a fundamental step to help us comprehend our data and draw better conclusions and explanations from the results. Task 1. Plot one interactive box plot per each variable in the dataset. This will help us to better visualize anomalies and or outliers in the data distribution. Array of column names. Let variables equal names of biodeg, and the variables are here. Create a box plot of each variables. For I in 1 to length of variables, and inside curly braces, we have let P equal box plot of biodeg variables I. This is for each column, comma, main equal paste bracket box plot for comma the column name. So what it prints is box plot for SPMXL. So these are the values. Box plot for JDZE, and these dots above show possible outliers. Box plot for NHM, box plot for F0NN, box plot for F04CN, box plot for NSSC, NCB, C, NCP, NO, F0CN, HDSSC, HYWIBM, LOC, SM6L, shut up, ME, MI, NNN, NARNO2, NCRX3, SPPOSABP, B0CBR, B03CCI, N073, SPMAX, and so on. So, box plot for class. So we have two classes, 1 and 2. This seems to be not right. Okay. Box plot is not a good fit for the class with the two levels. Task 2. Plot a histogram or a probability density distribution plot of each of the variables to see the distributions. Plot histogram of all variables. For I in 1 to length of variables -1. So we are excluding class variable here. Let P equal histogram of the column names, comma, main equal paste hist plot for variables I, X label equal variables I, close the curly braces. So we have the hist plot. Hist plot for SPXL shows that it is left skewed. Hist plot for JDZE shows that it is right skewed, and NHM shows right skewed. F01NN shows there are 3 levels. F0CN shows right skewed. NSSS shows right skewed. NCB is right skewed. C is bit better, left skewed, and so on. So we want to see histogram of a specific variable, then we can refer to this. So now next we see has dot numeric of biodeg at class. So it's either 2 or 1. Find the numeric values of factors. So data.frame of unique of biodeg at class, comma unique of has dot numeric of biodeg at class. The purpose of this is to match the numeric values to the class values. So we can see that RB his numeric is 2 and RB his numeric is 1. Count occurrences in class. Table of biodeg at class. NRB is 699. RB is 356. Table of S dot numeric of biodeg at class. So NRB is 1 is 699. RB is 2 is 356. Plot histogram of the class variable. Let P equal hist of S dot numeric of biodeg at class, comma main equal histogram of class, his numeric, comma X label equal class. Task 3. We identify all the missing values in the data, fill them, then double check if we still have those missing values. Find the missing values, which of is.na of biodeg gives us nothing. So there is no missing values. And as we know from the description of the file that there is no missing values.